Okay, good evening all. It's been a long time since we have continued the classes. So in this class, we will be discussing about Newton's laws of motion, part 2, which is problem discussion. Okay. I hope I'm audible for all of you guys, since in last class many people were complaining about the mic issue as well. Okay. So recently, uh, previous ETC exam results were published. So many people were wondering when the next recruitment will be. But don't worry, we firmly believe that in 2024 or in late 2024 or in early 2025 we can expect recruitment. Okay, this is the promise that we can give. Okay, but please stay tuned to our classes and also subscribe to this channel. Okay, so let us start with the class. First question: a block A of weight 100 Newton rests on frictionless inclined plane of slope angle 30°. A flexible cord attached to A passes over a frictionless pulley as shown in the figure and is connected to block B of weight W. We have to find the weight W for which the system is in equilibrium. Okay, here what happens is that in equilibrium we can see a force called mg sine theta. Okay, so in equilibrium, the force mg sine theta acting on block A will is parallel to the plane. It should be balanced by the tension in the string. That is, you answer in equilibrium. Okay, in equilibrium for block A. Block A. For block A, the force mg sine theta will be balanced by the tension in the string for block A. So it will be like this: mg sine theta will be equal to the tension, which will be equal to the force. That will be our equation number 1. Okay, similarly for block B, for block B for block B, equation will be like this: there is no mg sin theta mg cos theta weight acting on block B. It is simply denoted as W. So what will it be? W will be equal to tension, which will be equal to the force, which is our equation number 2. Okay, from equation number 1 and equation number 2 we can write like this: the weight W will be equal to mg sine theta. Okay, now we have deduced the relation, right? So from that, what we can write? From that we can write like this: W is equal to mg sine 30, right? Which is equal to, what is the value of mg? The value of mg is already given the question. Weight 100 Newton. 100 Newton means mg, that is force, already given. 100 into what is sine 30? 1 by 2. So the answer is weight is 50 Newton. Simple question. This question can be asked surely for the next ATC exam. Okay, write an entrance point like a note. Note. While finding normal reaction in such cases, we should be careful. It will be normal reaction. Normal reaction. In this case, normal reaction will be n equal to mg cos theta. So if you see a similar question like this in future, if they ask you to find the normal reaction, we can directly apply this formula, no need to reduce the equations like that. So we can conclude like, if you want to find the weight, we can use W is equal to mg sine theta. And similarly, if you want to find the normal reaction, we can use this equation, n is equal to mg cos theta. Okay, so what is this theta? Theta is the angle of inclination. Theta is the angle of inclination. Okay, Okay, everyone, please write it down. Okay, let us go to the next question. Okay, next question is like a good question. It has been asked in various JEE advanced exam and all. This question is also short question for ATC. Okay, okay. So let us read the question. A 100 kg gun fires a ball of 1 kg horizontally from a cliff of height 500 meter. It falls on the ground at a distance of 400 meter from the bottom of the cliff. We have to find the recoil velocity of the gun. So first of all, let us write down the given data which is present in the question. What is the mass of the gun? Since it is starting from the gun, we can denote the mass of the gun as m1. Okay. Mass of the gun, comma m1 equal to what? 100 kilogram, right? What is the mass of the ball? Just 1 kilogram. We can denote it as m2. Mass of the ball, comma m2, which is equal to 1 kilogram. Okay. What is the height of the cliff? Height of the cliff is h is equal to 500 meter. Okay. What is the horizontal distance traveled by the ball? Okay. Horizontal distance traveled by the ball is, I'm denoting it as x. X is equal to 400 meter. That is, we can, if you want to draw a figure, it will be like from this point, let us gun, it fires the ball, so it will be traveling with an initial velocity u, right? So this is the height of the cliff. Height of the cliff is given as like what, 500 meter, right? Ball will travel at a distance of 400 meter until it reaches the ground. Okay, so this is 400 meter. Okay, so what we have to find? We have to find the recoil velocity of the gun. So we have to use the principle of conservation of linear momentum in order to find the recoil velocity of gun. Okay, so since it is starting from gun, we have denoted as m1. So most probably the recoil velocity of the gun, we have to denote it as v1. Okay, so recoil velocity of the gun, let recoil velocity of gun be v1. Okay, okay. According to law of conservation of linear momentum, according to principle of conservation of linear momentum. Okay, according to principle of conservation of linear momentum, we know the equation m1 v1 equal to m2 v2. Here what all data we have? We have m1, we need to find v1, we have m2, but we don't have v2. That is, v2 means we have to find the velocity of the ball. Okay, so in order to use that, we can use the help of this equation. Distance is equal to speed into time. I'm denoting the speed as u into t, where u is equal to v2. Okay, but we don't have t. In order to find t, we can use the help of h. Okay, we know that h is equal to ut plus half gt square when g is given, right? Okay, since in this equation u is 0, so it is initial velocity. There will be no initial velocity, so we can write less h is equal to half gt square. Okay, so what is this h? We know that h is equal to 500 is equal to half into 10 into t square. Okay, after further calculations, we will get the value of 10 as t as 10 seconds. Okay, with the help of this t, we can find our v2. So v2 will be equal to x by t. What is x? X is 400 by 10, which is equal to 40 meter per second. Okay, now we can find the recoil velocity of the gun, right? m1v1 is equal to m2v2. So you can write this as equation number A. Okay, equation number A implies v1 equal to m2 v2 by m1. Okay, what is m2? 1 into 40 divided by 100, right? 100. So the answer is 0.4 meter per second. This is the answer. Okay, it's a simple question. We have to utilize many formulas just to find it. So the main formula here lies is m1v1 equal to m2v2, which is the principle of conservation of linear momentum. Then we have used this equation, x is equal to u into t, distance is equal to speed into time. Then we utilize this equation, h is equal to ut plus half gt square. Then fundamental concepts here. Okay, so let us move on to the next question. Just read this question, guys. Okay, this is also an easy question, guys. So the problem that many students face is that during exam, if they see a graph in a question, they will fail to skip that question because they will think the question is very tough because it has graph and all. We have to formulate the equation from the graph. But if you know all the concepts related to graph and all via mathematics, it's very easy to solve it. Okay, so here we have two graphs. One is xt graph and one is yt graph. Xt graph is a straight line, like directly proportional. Yt graph is like an inversely proportional graph. Okay, if a particle has mass of 500 grams, we have to find the force, direction and magnitude acting on the particle. Simple question. Okay, so here from diagram A, so now let us find the force on diagram A. Okay, so write the heading as like this, diagram A. Diagram A. Okay, so clearly from diagram A, the variation can be related as, since it is moving in straight line, we know that it's directly proportional. So we can write the equation will be like this, x equal to t, right? Let us just differentiate dx by dt is equal to 1, right? Again, let us differentiate d square x by dt square, which is equal to 0. What is that? It is equal to acceleration. So what is the force in this stage? Fa will be 0, right? Because force is equal to ma. There is mass is given in question, but in this diagram A, acceleration is 0. We found out that by differentiating. So Fa equal to 0. Okay. Now let us check for diagram B. Diagram B. Diagram B, the relation will be like this. It's like a parabolic relation, like parabolic. So it will be like this, y is equal to t square. So let's differentiate dy by dt is equal to 2t. Let's again differentiate d square y by dt square is equal to 2, which will be our acceleration. So what's the force in this case? Fb. Fb is equal to mass into acceleration. Mass is 500. This is in grams. We have to convert to kilogram into 10 raised to minus 3 into 2, right? So the answer will be that 1 Newton. So Fb is equal to 1 Newton. Okay, 1 Newton. Sometimes in question, so the answer is complete. Okay, Fa is equal to 0 Newton and Fb is 1 Newton. Okay, sometimes they will tell us to find the net force. Okay, in order to find the net force, the equation is like this: net force comma F is equal to root of Fa square plus Fb square. Okay, which is equal to what? Fb is equal to what? 1 Newton. So the resultant force will be along which axis? X-axis or y-axis as per the question? Along y-axis. Okay. this was an interesting question for you guys. There is sure chance that this question can be asked for next ATC exam. Let us go to the next question. Okay, let us read the question. A person in an elevator accelerating upwards with an acceleration of 2 meter per second square tosses a coin vertically upwards with a speed of 20 meter per second. After how much time will the coin fall back into his hand? Interesting question. Let us solve it. Okay, so here, what's the initial speed of the coin? U. Initial speed of the coin I'm denoting as U. What is it? 20 meter per second, right? 20 meter per second, right? Okay, what is the acceleration of the elevator? A. I'm just writing down the given data first, because with the help of the given data we can figure out which equation to solve it. 2 meter per second square. Okay, what is the acceleration due to gravity? G equal to 10 meter per second square, right? Since we have two acceleration here, we need to find the effective acceleration. Okay, so here the effective acceleration is, I'm denoting it as A dash. A effective acceleration comma A dash is equal to A plus G. A plus G. Okay, that is 12 meter per second square. Okay, how A plus G came I will explain at end. It's an equation, it's like a given note, like an entrance point. If you know that entrance point is easy, or if you want to know everything, just read NCERT textbook. By that you will understand where this formula is coming. Okay, so it's just like a short trick. To find the effective acceleration when the lift is moving upward, we have an acceleration due to gravity G and an effective acceleration A. Then the effective acceleration A dash is equal to A plus T, which is equal to 12 meter per second square. Okay, because here acceleration is with respect to the lift, we can write like this: acceleration with respect to lift. Okay. Okay, if the time of ascent of the coin is t, okay, if time of ascent of coin is t, time of ascent means I'm flipping a coin is going upwards, and that upwards is called time of ascent. Okay, time of descent means the coin reaches upward, and when the coin falls back into the hand, that is the time of descent. So we know that time of ascent will be equal to the time of descent whenever we flip a coin upwards, right? Okay, so we have to find this t. With the help of t, we can find the total time when the coin will fall back to the hands. Okay, did you understand, guys? Here they're asking like how much time will the coin fall back into his hand. Assume this point is our hand. I am flipping it. It goes up, right? So it will take a ascent time. When it reaches up, it needs to come down to my hand. Then it will take a descent time. So let's just find the ascent time, because ascent time will always be equal to the descent time. If we just find the ascent time and just add it once more, we'll get the total time. That is total time for the coin to reach back into his hand. So why we found a effective acceleration? Because we need the help of the effective acceleration to find the value of t here. Okay, so we know this equation: v is equal to u plus at. V is equal to u plus at, right? Here there is no mention of final velocity here, so we can take it as 0. 0 equal to 20 plus 20 plus minus 12 into t, minus 12 into t. B. One second, guys. Okay, guys, for this question, instead of going for this equation derivation, we can directly go ahead with the formula to find the time of ascent and descent as well. Okay, that is the total time of the coin, that is time of ascent. We can be founded this by this formula. I'll just erase this. If time of ascent of coin is t, then we can use this formula to find the time of ascent. T is equal to 2u by a dash. Okay, not 2u is equal to t dash is equal to t dash is equal to 2u by a dash, where 2 into 20 divided by 12 is equal to 40 by 12. 4 tens are 40, 4 3. So 10 by 3 is the total time in which the coin will fall back into his hand. Okay, 10 by 3. So here what is t dash? T dash is the total time, that is time of ascent plus time of descent, total time. So we can write here t dash, the total time, that is time of ascent plus time of descent. We can use this direct formula to find it instead of deriving it from the b equal to u plus at, because that formula is actually derived from that formula. So this is just a shortcut method. Okay, so let me give some entrance points for this question. So while calculating net acceleration, we should be aware that if lift is you can write a note. Lift is going upward. If lift is going upward, then the net acceleration is g plus a. Net acceleration is g plus a. Okay. If lift is going downward, then net acceleration is g minus a. Okay, so it's a simple question for this question. Okay, so I hope you all understand it. Write down the data, follow the concept, just be aware of this tiny formula here. T dash is equal to 2u by a dash, where t dash is the total time for the coin to reach back into his hands, that is the time of ascent plus time of descent is t dash. U is the velocity, which is the velocity. A dash is the effective acceleration based on how the lift is moving, that is accelerating upwards or accelerating downwards. If there is no acceleration of the lift, then net acceleration will be equal to g. Okay, let us move on to the next question, guys. Okay, nice question. This type of questions we can expect in AAIATC exams. Okay, AAIATC exams. So a woman throws an object of mass 500 grams with a speed of 25 meters per second. What is the impulse imparted to the object? If the object hits a wall and rebounds with half the original speed, what is the change in momentum of the object? Okay, first of all, let us write down the given data. What is the mass of the object? M is equal to 500 gram, which is equal to 500 grams, which is equal to 0.5 kilogram, right? Okay, what is the speed of the object? That is v. V is equal to 25 meter per second, right? So first of all, we have to find the impulse imparted to the object. What is the formula for impulse? Impulse I is equal to change in momentum. Change in momentum, which is equal to mv minus mu, which is equal to m into v minus u. Okay, which is equal to, what is m? M is 0.5, v is given 25, u is not given the question, which is equal to 0. Okay, 0. So after calculation, 0.5 we can 1 by 2, 25 by 2 is 12.5. 12.5 Newton second. Newton second is the unit. Okay. Here given speed is not u, it will be v, because after the woman throws an object of mass 500 gram with the speed of 25 meter per second means final velocity will be 25 and the initial velocity will be 0. Okay. Okay, so in this case initial velocity will be 0, final velocity will be 25. Okay, so what's the second question? The second question, there will be quite few changes. That is, here they're also telling us to find the impulse. Instead of that, they just twisted the question such that to find the change in momentum. Those who know the definition of impulse knows that first question and second question is absolutely the same, but just a small condition in the second question is given. Okay, that is second question also we have to find the impulse, that is change in momentum. Okay, so what's the condition given? Object is, okay, this is the assume this is the ball. Object has hit the ball. This object has hit the ball. It rebounds with half the original speed. Okay, half the original speed means we know that original speed is v is equal to 25 meter per second. Okay, so in this case, in the second case, this v will become our u. That is, in this case, u is equal to, for b, u is equal to 25 meter per second, because it is already traveling with 24 meter per second before hitting the ball. After hitting the ball, it will rebound with half the original speed. At that time, b will be half the original speed, be 25 by 2. Since rebounding means in the opposite direction, we have to give minus here, meter per second. That's the only difference in this answer. Okay, now we can directly apply the formula, that is change in momentum equal to m into v minus u. Okay, which is equal to 0.5 into minus 12.5 minus 25. Okay, so the answer will be minus 18.75 Newton second. Okay, such a simple question, guys. Let us move to the next question. Okay, next question, interesting one. This question is also expected. Okay, in this question, mass is given, m is equal to what, 2 kg. Velocity of the body is given, v of t is equal to 2t I cap plus t square j cap. Okay, we have to find the momentum and the force acting on it. Okay, so velocity of the body at t is equal to 2 seconds. Okay, first of all we have to find the velocity of the body at t is equal to 2 seconds, then only we have to find the momentum and the force. So v of 2 equal to 4i t square 4 plus 4j. Okay, now we can find the momentum. What is momentum? P is equal to mb, is equal to 2 into 4i plus 4j is equal to what, 8i cap plus 8j cap. Okay, we have found that. Now what we have to find? We have to find the force. Force, we have to, what is the formula for force is equal to mass into acceleration, but we don't know acceleration. With the help of v of t we can find acceleration. A is equal to dv by dt, right? dv means 2i cap plus 2t j cap. Okay, at t is equal to 2 seconds, at t is equal to 2 seconds, acceleration is equal to 2i cap plus 4j cap, 4j cap. Then force, F is equal to ma, which is equal to what, m is 2 into 2i cap plus 4j cap is equal to 4i cap plus 8j cap. So that's the answer, Newton. Newton. This is unit is kilogram meter per second. Okay. So we got the answer, right? Simple question, guys, just differentiation here. Okay, let's move on to the next question. Okay, let us do this question first. It's also a similar question. Okay, then we will move on to the graph type question. That graph type question is quite somewhat important, so we'll come back. Don't worry. Okay, so cricket ball of mass 150 grams. Okay, so first of all, let us write down the data. Mass is given 150 grams, which is equal to 0.15 kilogram, right? 0.15 kilogram. Okay, what is given? U is given, initial velocity U is equal to 3I cap plus 4J cap. Okay, final velocity is given, V is equal to minus 3 minus 1 second. Okay, minus 3I cap plus 4J cap. Okay, what we have to find? We have to find the change in momentum. That is initial final momentum minus initial momentum. That is delta P. That's it. Delta P is equal to mv minus mu. This is equal to m into v minus u. Just apply the values. That is 0.15 into minus 3I minus 3I minus 4J minus 4J, and just gathering it together. Let's just write the final answer, since it's just calculation here, no big logic. Minus of 0.9I cap plus 1.2 J cap. So this is the answer. Okay, it's an easy question, guys. I hope all of you understood. Okay. Okay, so this question is continuation of this question. Okay, here what they are asking in previous problem 3, the magnitude of the momentum transfer during hit is, we have found the momentum, that is delta P is equal to minus of, we have found the momentum as delta P is equal to minus of 0.9 I cap minus of 0.9 I cap plus 1.2 J cap, right? We have found delta P. Now we have to find the magnitude, right? So magnitude will be like this. Magnitude is equal to mode of delta P, okay, which is equal to root of 0.9 the whole square plus 1.2 the whole square, okay, is equal to root of 0.81 plus 1.44. Sometimes in question there won't be this much values, okay, but those who are studying aptitude, it will be very easy for them. When you take the root, the final will get around 2.25, so the answer will be 1.5 kilogram meter per second. Okay, let's go to the next question. Okay, this is a theory question. I'll just explain. Okay, conservation of momentum in a collision between particles can be understood from A, conservation of energy, B. Newton's first law only. C. Newton's second law only. D. Both Newton's second law and third law. Okay, so write a note. For conservation of momentum, we have to see whether net force is acting on a system or not. I'll repeat. For conservation of momentum, we have to see whether net external force, not net force, net external force is acting on a system or not. Okay, here the answer is D. That is, the conservation of momentum in a collision between two particles. Particles can be understood from both Newton's second law and third law. Okay, both Newton's second law and third law. I provide an explanation. Like, we know that for a system, the external force is given as dp by dt. Okay, from Newton's second law. If external force is equal to 0, if external force is equal to 0, dp is equal to 0, which implies momentum p is a constant. Okay, hence momentum of a system will remain conserved if external force on the system is 0. In case of collision between particles, equal and opposite forces will act on individual particles by Newton's third law. Hence the total force on the system will be 0. Okay, we should not confuse with system and individual particles, as total force on the system of both particles is 0, but force acts on individual particles. Just note this point down. Okay, this question can be asked as a sure type theory question. Okay. Just on to the next question. A body with mass 5 kg, mass is given as 5 kg, is acted up by a force. What is the acting force? Acting force, comma, F is equal to minus 3 I cap plus 4 j cap Newton. If its initial velocity at t is equal to 0 is u is equal to 6 I cap minus 12 j cap meter per second at t is equal to 0. Okay, then the time at which it will have a velocity along the y-axis is. Okay. Here, first of all, we need to find the velocity along y-axis, because when we find the velocity along the y-axis with the help of this equation v equal to u plus at, we can find the time along the y-axis. So this we have two things now: velocity along x-axis, velocity along y-axis. If we have find the velocity along y-axis, we have the u, we can find a, then we can find t. Because how we can find a is equal to f by m, right? What is force? Minus 3 I cap plus 4 j cap by what is m? 5. So the force is so the acceleration is minus 3 by 5 I cap plus 4 by 5 j cap. So now we have found the acceleration. We know u. Well, now we need to find v. Okay. So in the question, it is given that the time at which it will have a initial velocity along the y-axis is. Okay, here it is mentioned the question that final velocity along y-axis is given. Y-axis exists or given, which means that final velocity along x-axis is 0. Okay. Mention the question because there's a time at which it will have a velocity along the y-axis. That means that there is a final velocity along the y-axis, but there is no mention of final velocity along the x-axis, which means that we can say that final velocity along x-axis equal to 0. Along x-axis it is equal to 0. So with the help of this we can find the answer. That is final velocity along the x-axis, we can write like 0 equal to u. We can take the x coordinate only. Okay, when we write u, we have x6 I cap minus 12 j cap, but here we can only take the x part because we are writing in terms of like this: vx is equal to ux plus ax into t. Okay, we are formulating the equation like this because we have found that the final velocity along the x-axis vx is equal to 0. There is a final velocity along the y-axis, but we don't know what it is. But we can conclude that there is no final velocity along the x-axis. So I took vx is equal to 0. So what is ux? Just take the x component. 6 plus a minus 3 by 5 into t. Okay. Now we can find t is equal to 5 into 6 by 3 is equal to 10 seconds. So the answer is B, 10 seconds. Okay, see, simple question. We just need to understand the concept. Without understanding the concept, we can't solve the questions. Okay, just hold on. So let us continue. So this is the last question of today's session. Okay, it's an interesting question. Let's try it out. Okay, so here the position time graph of a body of mass 2 kg is given. We have to find the impulse of the body at t is equal to 0 second and t is equal to 4 second. So initially mass is given, that is m is equal to 2 kilogram. Okay, so firstly we can see that from the position time graph, when the body is at x is equal to 0 and when x is equal to 0 and when t is equal to 0, the body is at x is equal to 0 and t is equal to 0 implies what happens? The body is at rest. Body is at rest. Okay, at that time what is impulse? Impulse will be 0. Okay, impulse at t is equal to 0 will be 0. Okay, from t is equal to 0 to t is equal to 4 seconds, the position time graph is a straight line, right, which shows that the body moves with uniform velocity. That is, t is equal to 0 to t is equal to 4 seconds, 0 seconds to t equal to 4 seconds, body moves with uniform velocity. Body moves with uniform velocity. Okay, also beyond t is equal to 4 seconds, graph is a straight line parallel to time axis, which means at that time body is at rest. That is, v is equal to 0 at that time. Okay, beyond t is equal to 4 seconds, body is at rest. Also, body is at rest. Okay, since the position time graph is a straight line parallel to x-axis, that is time axis. In order to find the impulse, we need to find the velocity. We need the help of velocity, initial velocity and final velocity. Okay, so in order to find the velocity of this graph of this body, we have to find the slope of position time graph. That is, velocity of the body will be equal to slope of position time graph. Position time graph, what is it? It is equal to tan theta, which is equal to 3 by 4, right? With the help of this, we can find the impulse on the body at t is equal to 0 second and t is equal to 4 seconds. What is the impulse of the body at t is equal to 0 second? We have already found it as 0, right? Now we have to find the impulse of the body at t is equal to 4 seconds. Okay, let me check whether we have it in next page. Okay, impulse at, we have already found that impulse at t is equal to 0 equal to 0. Now we have to find the impulse at t is equal to 4 second. We can use the change in momentum equation, that is m into v minus u, right? So at t is equal to 4 second, what is v and what is u? In this case, the initial velocity will be, because we can see that when t is equal to 4 second, where will we mark the initial velocity? That is in the graph. It will be like this. Graph is like this. It will go here and here. Okay, so this is our t is equal to 4 seconds, right? 4 seconds, this will be our u and this will be our v. So I have already told that beyond t is equal to 4 seconds, body is at rest. That is, when body is at rest, we know that v is equal to 0. So here absolutely the v will be equal to 0 at t is equal to 4 seconds, because u will be equal to 3 by 4, right? Because I have already found the slope of position time graph. So we can take the velocity of the body as 3 by 4 as u only, because it's like that as per the graph. So we can apply for v, it will be 0, because v denotes it's beyond t is equal to 4 seconds. U means the initial velocity at 4 seconds, minus 3 by 4. What is m as given in the question? M is 2. 2 into minus 3 by 4. Okay, is equal to minus 3 by 2 kilogram meter per second, which is equal to minus 1.5 kilogram meter per second. See, simple question. Just understand the graph and we can do it, guys. Okay. So this is it as for today's class. I hope all of you understood the class. Many important questions were discussed in today's class. So everyone, please go through these questions. This much questions is enough to practice on Newton's laws of motion, rewind all the formulas, and we will see in next class with a new chapter, work, power and energy. Okay, hope all of you understood the class. Thank you and goodbye.